Welcome back to the stream. My name is Jared. This is part 2 of my sort of bonus afternoon stream today, where I am working through Advent of Code problems. We just finished day 19, and I'm going to do day 20 now. So let's, without further ado, excuse me, let's get into it. So, Jurassic Jigsaw. The high-speed train leaves the forest and quickly carries you south. You can even see a desert in the distance. Since you have some spare time, you might as well see if there is anything interesting in the image the Mythical Information Bureau satellite captured. After decoding the satellite messages, you discover that the data actually contains many small images created by the satellite's camera array. The camera array consists of many cameras. Rather than produce a single square image, they produce many smaller square image tiles that need to be reassembled back into a single image. Each camera in the array returns a single monochrome image tile with a random unique ID number. The tiles, your puzzle input, arrived in a random order. Worse yet, the camera array appears to be malfunctioning. Each image tile has been rotated and flipped to a random orientation. Your first task is to reassemble the original image by orienting the tiles so they fit together. To show how the tiles should be reassembled, each tile's image data includes a border that should line up exactly with its adjacent tiles. All tiles have this border, and the border lines up exactly when the tiles are both oriented correctly. Tiles at the edge of the image also have this border, but the outermost edges won't line up with any other tiles. For example, suppose you have the following 9 tiles. By rotating, flipping, and rearranging them, you can find a square arrangement that causes all adjacent borders to line up. For reference, the IDs of the etc. To check that you've assembled the image correctly, multiply the IDs of the 4 corner tiles together. If you do this with the assembled tiles from the example above, you get such and such. Assemble the tiles into an image. What do you get if you multiply together the IDs of the 4 corner tiles? Okay, that makes sense to me. So we can take a look at the puzzle inputs. Sort of what we expect. Nothing out of the ordinary there. Rotated and flipped. Okay, interesting. All right, get set up. Day 20 part 1. Generate our scaffold and pull our input in. Grab our test input. Hello? Oh, that's not gonna work. Rude paste mode with its tabs. Oops. Come on, does this fix it? Yeah, there we go. Don't want no tabs in our Ruby files. And this should produce the answer, some big number. Doesn't really matter. That'll just be sort of our smoke test to know whether we've got this thing working properly yet. We're gonna want some, oops, some kind of tile class, but I don't exactly know. What that's gonna look like. So leave that for now. I want a parser though. Maybe it just spits out these tiles. Parser.new input. We'll just parse the first couple. Cert equal 2311 parser dot tiles first ID, and so that's failing because what? One failure, 0 errors. What's going on? What am I missing? 2 assertions. Why is my parser test? Oh, go. Now we get what we expect. This is just an adder reader. Just do all the work inside of the constructor. Input dot split on double new lines to get each individual tile. Map those. And probably store everything as nested arrays. Booleans, I guess. So lines equals tile that split on new lines. Just single new lines. And we need to build a new one of these things. Its ID is going to be lines.first dot split on space last to I. And we can, for the purposes of the test we've written, we don't actually care about what's in the next field. Undefined tiles. What am I calling tiles? I called this rules because I had my head stuck in the previous problem. So there we go. That passes, but does not tell us anything useful. So I'm going to make a single This is a tricky one. How do we want to map this in memory? Is this 0, 0? And this 0. No, this is 9, 0. Which means it's not easy for me to transform this into, I guess. Okay, let's just transform it into the raw thing. It's gonna be ugly, but let's do it. Okay. It's all right. Need to make this into. Well, first we can wrap it. And then I can replace all of the hashes with true, comma, space. And all of the dots with false, comma, space. And then just need to clean up those trailing guys there. Okay. Well, it's not pretty, but I don't need to do this, but it's just gonna look so much nicer if I do. There we go. Okay. Hopefully that'll make it a little easier to read, but go. And now we need to write the code that actually does that, which is fortunately fairly simple. Lines dot, and we don't want the first, so we want the second to the last, so we do that. And then we need to map each line. And those lines themselves are going to be the characters mapped. When it's a dot and a false. Oh, that's not, that's excessive. This is just, that is good enough. And see if that works. Does not. Is very close to the same though. I can't see a difference. Both tiles, they both have the right ID. True, false, false, true, false. True, false, false, true, false. It looks exactly the same. True, 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 false, false. True, false, false. What? What's going on? What way are these different? These look the same. Okay, let's extract it to a variable so I can actually put ground in here. Let's clean up how we format that. What do they call this field? Data? Is that quality not working for these the way I expect? Oh, I see 1951. I typoed the ID. Oh. Brutal. Should have looked for the simple solution. Classic mistake. All right, so that gets us that. So now we can parse these things and we have them in something vaguely resembling a data structure that could conceivably be useful. Now I have a few questions. One of them, so so that's 12 by 12, right? Well, what is that of my times tables, multiplication tables, whatever we call them. How do we square root things in? That seems like it might be useful, knowing the putting that there just in case I need it. Okay. So what's the approach here? There's a border that should be lined up exactly with its adjacent tiles. So I do want to be able to rotate these tiles, potentially. And flip them and stuff. Maybe we should implement some functions on our tiles just to sort of give us some more tools here. Then we can sort of get moving from there. So test horizontal flip, maybe. So we've got the data in there. Actually, I want to test 2S. So we've already got this thing here. got this helper function, and I want to make some kind of assertion about this. So like we know this tile, like why don't we just make it so we can print out that? Assert equal output new tile 2s. Something like that. Thank you. That's going to be annoying really quick. Get rid of that. Okay, so it gets a bunch of stuff that is totally different and hilarious. So we're just going to do an array of, we're going to do some things anyway. We'll see where it gets us. Come on, there we go. So the first thing we know we want in here is tile ID : so those are similar. This is actually output.strip. I think we've got a new line at the end that I don't want. Yeah, there we go. All right, and then it is data.reverse.join, or I guess we need to map it to just doing the reverse of what we did before. Should we have new lines in between and fail at writing valid Ruby? Neato. And this outer, this is a join, this is a join, new lines. That's what I do wrong. Now things are closer. I mean, it's looking like this reverse was wrong, which makes sense. Right, I was thinking about doing this differently, but okay, cool. So we now know this handy test here shows us the visualization of our new tile so that we may write additional new tiles or write additional tests that take that into consideration. Where to next? Do we want to rotate it? Say horizontal flip. So that's a little bit easier to write. Because Because we can write a similar test. We say dot h flip. And it's the easiest way to flip this inside of Vim. It's not so many steps to do it manually. If anyone has a suggestion for a faster way to do this. I am all ears. Especially how clunky I'm doing this. Control V. Whew. Well, thank you, one viewer, for sticking with my journey of flipping that. Okay, it's going to tell us that method doesn't exist. Then we can go implement it. All right, so that looks, I think, superficially looks like I flipped that correctly. So we can write a horizontal flip. And the way our methods on these are going to work is they're just going to return a new tile that has the new data. And I just think that's the easiest way to handle this. So we do this, and then we do some transformation to our data here. And here we just need to reverse the sub lists in order to do that. In fact, we can write that more simply. And that works. Okay, so that's clunky setup, but we got it. Now let's try a vertical flip. I guess I should base it off this one. So we do V flip in here, and I'm gonna do the same fun thing I did before, but it'll be easier because they're rows. Probably write a macro to do that. I think of faster ways to do it. I guess I've already done it now, so. And that will fail. V-frip. V-frip. Okay. Okay, and that passes. Now we have to do the rotations. And I'm gonna, for now, assume that we can only rotate one direction. Because that's easier. As far as writing this, building this test though, I should have used a smaller tile example. We can do it for this test. That way it's not hell. So it has an ID, and then let's just pass in the data, and we'll just make this like a 3x3 tile so that it's manageable to rotate in our heads. guess it's probably nicer to format it like that. Cool. And we won't use new tile here. Instead, we will oh, I just said ID here. Put an ID in. And we should be able to rotate this one in our heads a single time. And it should say, so let's say we'll just go clockwise. So this will be false, false, true, false, 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 oh, false, 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 true, true. Is that what I drew? I think so. Define method rotate. That's what we expect to hear. What is the easiest way to do that? Any Ruby array methods that I can think of that make this at all easier? Rotate, perhaps. No, rotate doesn't help us. That would be cool, though. Can we use like zip to do rotate? Is that how that works? I'm trying to make sense of that in my head. So if we've got input is true, false, false, or true, false, true, false. What did that do? So this was, that did rotate it. What about a bigger one? What, so is it data.first .zip data one Did that rotate it? That's just gonna, I'm not calling tile that new or anything. Wrong number of arguments, line 81. Is that because I can't pass multiple things? Oh, that's really hard to read that diff. Not helpful. What do you got? It's 1951. Oh, I see. Rotated? Nice. Thanks. I'll see if that comes in handy. Try and get it working on the smaller ones first here. Now, let's just pry inside of here and see what we can see. So tile to us, we can like output a tile here. That's our tile, and then so that that didn't quite rotate it. That rotated it and mirrored it. Well, that's very close to what we need. Okay, so that works. Not the most beautiful solution, but now we need to support it for multiple iterations. Be able to rotate it multiple times. So we want rotate 2 to get us not to here, but to there. But sadly that does not work. So maybe our thing is not as general purpose as I'd hoped. So that looks like. Interesting. Oh, I didn't actually implement this method. Great. This is great. Tile equals self n times well, that doesn't look like it passed. Where's my pry? Okay. So sadly that is not passing still. So what am I doing wrong? Oh, I see a mistake. Okay, there we go. That fixed it. Okay, so now we can rotate. We can do vertical and horizontal flipping, and I also have a coffee. A long overdue coffee. I already had one today, but heavy lunch. All right. Okay, so we've got a bunch of tools for doing this, but now we need to actually sort of thanks. I don't 100%, like, it's one of those ones where I like wrote it and don't 100% know why it works, but like I can kind of visualize it and it works, so good enough. I don't actually remember where I'm at in this puzzle though now. So we'll see here. So I need to find an arrangement where this is a 12 by 12 grid, and I can arrange the tiles in any orientation. I feel like it's probably xy equals xy sort of zip sort of. Oh yeah, that makes sense. Sort of like the math you do to like rotate a vector or something, yeah, but generalized for more for a full matrix or whatever. That makes sense. Okay. what's the easiest thing? So I can like generate all of the possible edges for each tile, and I guess I can try and look to see if tiles at the edge also have this border, but the outermost edge won't line up with any other tiles. So maybe I want to find the edges first. Because then I could find the, I don't know. Like I want to solve this in sort of a general way, but I don't know what the immediate next step is. Here, just a sec, I need to take my sweater off. It is getting way too warm in here. Plus I'm rocking my nice Keep Ruby Weird shirt. Okay. I mean, I can try and find the corners first, I guess. Maybe? I don't know. This one seems tough. Like I don't see the paths super well right now. So maybe I write a method that returns all the edges of a tile, all the possible edges of a tile. So I feel like that's going to be important for sort of fitting them together. Again, I think I want to use my simple tile. We'll do it with sets because I think sets just makes the test easier, right? Honestly. So edge is going to be an array of possible things. So we want them to be unique. So we'll have true, false, true. That one's mirrored, so we don't have, or that's symmetrical, so we don't have to worry about it. The bottom edge is false, 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 which is also symmetrical, so we don't have to worry about mirroring it. Then we have true, false, false on the left, which could also be false, false, true. And we have true, true, false, which could also be false, true, true. I think I'm missing something. That's all the possible edges this tile could have. And I've left a pry somewhere. So we run that and we can see that this method doesn't return anything yet. So we have to write it. So I think this is kind of straightforward because data.first is the first row. Data.first.reverse is the first row mirrored. Data.last is the last row. Data.last reverse is the last row reversed. And then oops. Then we can just rotate it and grab the top and bottom again and call it good, right? Call this R. And this is r.data. just going to copy them. I'm just adding it. Cool. Okay, so we can grab all of the edges. And I foresee myself calling this lots of times, so let's just memorize it. Oops. Cool. We could probably memorize other stuff if it turns out we need to. So that'll come in handy. Another question is, can we find some tiles? So we have our tiles. Sorry, that's input. So we want what? The tiles where they share no edges with any other? Is that really going to exist? Is that how this is set up? T. Come on, brain. So t dot possible edges count something equals 2. We count the edges that if we figure out in here how to count the edges that aren't shared, be all the other things. So that's all of the other things. Edges. It's not pretty, but so that's what I was worried about. Either I've done that wrong, or that restriction is not like the most. So yeah, sorry, I guess I should explain myself. Whoops. I was trying to verify. It says all borders line up exactly. Tiles are both oriented correctly. Tiles at the edge of the map also have this border, but the outermost edges won't line up with any other tiles. I was trying to understand whether it was saying there exist tiles that have edges that can't match with anyone else, any other tile in the set, but because that would make this easier, but it appears to just mean that once the tiles are in place, those ones aren't matching up with anything because they're on the edge, as far as I understand it anyway. Oops, did it again. Okay, get the right thing on my alt tab here. So that's tricky. Oh, flat map doesn't work. Because they're sets. And that's not right either. Map it. Flat map 2A. Still doesn't produce any results, but that's probably the thing I meant to do. And sure, let's just. Okay, well, that was at least the thing that I meant. How do I solve this, though? I've done a whole bunch of work, but I think I just need to. I can try and like recursively fill this thing out with valid tiles until I find a solution. That seems like it might be prohibitively slow because what I've got like 144 tiles that need to be placed. They can each be placed in so what? 8 different orientations for each one. So all 4 rotations and then mirrored those 4 rotations. So that's a big number. I mean, we would be able to stop at any point where we have no path forward. I don't know why my pry history doesn't work. I'd like to know the answer to that. How do I tackle this now? So I could look for tiles that can only fit together, but what do I do with that information? I mean, the recursive solution just seems like it's gonna take forever. Oh, right, and since I'm only looking for the corner tiles, that trick I would have used would have made this problem really, really easy. So you wouldn't have to do any computing for the inner tiles. That would be funny. I lost sight of that. What to do? I mean, I'm tempted to just start writing the cursive one and hope that the... Oh, it's gonna just take forever though. There's no way that would work. Yeah, I have been doing them all in Ruby. I mean, the number of possible permutations for arranging these tiles, ignoring validity, is a number that that makes this not work. So even if I were writing this in like C or something, that solution would be a no-go. Unless the problems we've been given are like exceptionally restrictive, in which case I would like quickly enough discover no way forward as I did these. But it doesn't say anything. Some of the other problems suggested What is the trick here? Very nice, very nice. I like it. It's like the programming equivalent of draw the rest of the owl. Well, I guess one thing I could look for is input.any so let's say we take the inputs, we take all the tiles, we map them to their possible edges. We convert those to arrays. We flat map them to arrays. So now we'll have duplication. And then we can do group by itself. And then transform values into their counts. See if this provides us any interesting information about this problem. Oh. Well, this was probably for the smaller input, right? This is just the test running. So like these twos are like pairs of tiles that probably have to be lined up. But in the actual input, what do we get? Okay. So this is actually going to be super restrictive, because any given edge can only match with let's just double check that, but values unique. So edges only ever match with 0 or 1 other things. Okay, well, if it's that restrictive, then that makes this easier. That makes it way faster to realize whether a solution is valid and way easier to evaluate whether a given tile can even go anywhere, I think. So there are only 144 tiles that can go. So why did my math before not work? That's my next question. So I did I was looking for input. I needed ones that had possible edges isn't the right thing. Interesting. So this is kind of tricky still, but now it's coming together in my head. So maybe we can just search the space since it's so restrictive with like a recursive thing or something. Or not even a recursive thing. I guess it probably wants to be recursive so that we can do the sort of backtracking kind of bit correctly. Or let's just start down that path and see where it gets us. Maybe I'll have some revelation, but so kind of want a board class or an image, I guess it's supposed to be. Let's call it a map. I don't know. It's the bad name for it, but I don't need an initializer. So I want to be able to tell whether whether things are valid easily, and I want to be able to set a tile, which is going to return me a new instance. Sort of how I do everything. Test, set. So let's get the return of our nice little 3 by 3 tiles. Tile 1. Oh, I'm writing that. I'm putting that in the wrong place. Tile 1 and assert equal image new, and we're going to use a hash for that, I think. So image equals image.new. We're just going to initialize it with what we want. So that test is going to pass because it doesn't do anything. Cool. And then say image equals image set. And we're just going to go 0 to 12 or 11 across the top, and then 12 to 23 across the next line, et cetera, just for simplicity. And so that it gives us an order to iterate across. Cool. Given a method that actually exists. And a little bit more coffee in me. And we want to return a new image, and we pass into it index tile merge map. Or actually, I think probably want to do that separately. That way we're overwriting technically if it matters. Okay, that works. I'm just going to say test example. So we have placed tile 1 in the first position. Now we want to take tile 2, which does not fit next to it. Next to it, and refute image dot valid. Cool. So that test didn't actually force us to write anything, but we can do a little test here. All our tiles are ID 33, so that's funny. But if we change this to true here, then these will fit with each other. And then we can assert that our image is still valid at that point. And that doesn't work because we haven't actually implemented it, which is good. So what am I doing? So just remembering how this is going to look. So for a 3x3, the indexes go So we want to check first that our how do we do this? We may need additional methods on things. So we need to check above, left, right, below. Checking above is if tile above index probably something like this. It's gonna be ugly, but we'll figure it out. If there is a tile, then tile.bottom edge equals, oops, I can't call it tile. Let's just go t.top edge. Otherwise, wow. I might have to extract some of this logic here. Or true. That's probably not the best way to write that, but what I got so far. And it's supposed to be tile, not T. That is not pretty, but it also depends on a bunch of logic that doesn't exist yet. So I need like a tile above, and all this stuff, and that's gonna be clunky. What's the easiest way to do that? Should I just implement them all? I should have used XY coordinates. It would have been easier, but these are also not hard to write. Or are they? So where should I switch to using coordinates? Because it's almost certainly easier to do that. So I'd rather do like coordinates equals or whatever this is, x equals index percent or whatever. I don't remember what this math is actually supposed to be. So yeah, I think that's right. And y equals index minus x times tau updated on length. Is that right? That works. For index 0, let's see. For index 4. Whoops. I do this math right. X equals 1 and y should equal 1 as well. Okay, I guess that works. instead of this, we can do X and Y coordinates in here. So, I shouldn't. So just remember what we're doing. Above is the same X coordinate, but Y minus 1. Below is the same X coordinate, but Y plus 1. Tile left is the same left is X minus 1, Y is the same, and then X plus 1, Y is the same. We don't actually know the size of this thing. Here. But do we care? Yeah, we do care. Dang. So this is a 3 by 3, so let's pass in 3 then. And then we need to add size here. And then we just need to convert it back to an index. So we know if return if x is less than 0 or x is greater than or equal to size, or y is less than 0 or y is greater than or equal to size. Because then we know we've gone off the map, and then we can do the main logic here, which will be map, and then we look for y times size plus x. If I remember correctly how that math works. And now we got some errors because we got a size nil somewhere. Somewhere we are creating an image without passing in. Oh. Keep passing down the size. Okay, cool. And now it's failing because our methods we do not have top, bottom, left, right edge methods on our tiles. Thanks. Have a good night. Good luck with day 21. Thanks for the follow. All right, let's test our edges here. Def test edges, and we can tile equals new tile, and so this tile here is our new tile. So we can write tests for all of the edges. Let's do top tile.top edge first. which should be true, false, true, true, false, false, true, true, false. And it is nil instead, as expected. So it's just data.first, I think. Excellent. We'll do bottom edge second, since that is similarly easy. This is true, false, 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 true, true, false, true, false, false. That'll be nil, but fortunately that's similarly easy to implement. And now for the two tricky ones, left and right. Let's do right first. And right edge is false, true, 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 false, false, true, false. And if I understand correctly, I just need to rotate this once. Or sorry, I want the right edge. I rotate it once and take the bottom edge. And reverse it. Beauty. And we'll do left edge now. And left edge is true, true, false, true, false, false, true, false, true. I think this is rotate one top edge, probably reverse. Maybe. It is. And our validity test just started working. Well, isn't that nice? This is awful code, but I like it. I like it. I like this random little comment here. Goodbye, little comment. So this is tricky, but we now have the ability to start putting tiles in and testing whether the solution is valid. So what do we do here? So create a new image. And then we go what do we do now? Besides play with my terrible mustache. get a little more light in here. Dying light. Guess we can try naively. I think that won't work. We should be able to more easily find possible next tiles. Right? So like we could say like possible tiles, or say image. Maybe we'll ask the image for them just because that's where the data is. Filter tiles, we pass it our input and a position. That gives us all of the tiles that could possibly go in that position. I want to write out the algorithm before I start implementing the extra methods because I think I've been getting a little ahead of myself. We have all the possible tiles that could fit in a given position, in this case 0. Then we want to find a solution for the rest of the puzzle. So we could do, I feel like we're pretty close here. New image equals, or let's say we call solve on image dot set one tile so we're gonna want the solve method is going to be important, and it's going to take the map and the remaining tiles. So we're going to say solve image input. Oh, and we want to say 0. So it takes the image, the index that we're trying to slot one in for, and the remaining tiles. Filter tiles, remaining tiles that can fit into index 0, or sorry, that can fit into image index. This is index +1. This is remaining tiles minus tile. There's no base case here though. So this is not quite it. So So what is our base case? I feel like we're pretty close to this though. I'm gonna eat a cookie, and then hopefully that'll make me realize what I need to do next. Okay, so if we say next tiles equals image.filter tiles index remaining, we know here that we can return false if next tiles dot empty, unless we're at the end, but that's a separate issue. We can cover that case in a sec. Having trouble wrapping my brain around an recursion here. What does this return? I guess the other base case is just return image if image full and image valid. Maybe? That way, we were still going to get a nil value out of that, but let's just do that, I think. Boy. This is time consuming. All right. Need to implement filter tiles. So it's probably easiest to just get the constraints for the position, and then ask the tiles if they meet those constraints. So which is basically going to be this logic. So let's simplify this. Constraints should just be an array. Let's get rid of this thing after the equal sign. I've written a heck of a lot of code for this one. Like that. And let's put these in an order that makes any sense. So they will go in top, right, bottom, left, which is the same order as HTML attributes put their things, and is just sort of burned into my brain. Okay. Probably should write a test for that. Oh, but I don't want to. So let's not. Let's just go write the test for meats. And this is top, right, bottom, left equals constraints. And this is just top.nil or top equals top edge. We should actually test that one. So let's test only top edge. Top edge should be true, false, true. I have extra parens down there. Okay. That's good, that's good. Back to this, test meets. So we want to test that, and we probably want to test like a something slightly more fun. Top, test like a at the right also. Yeah, so that's working. No, we also see we have a failure, undefined method full. Let's do that. Full means that the map should equal size squared. Remaining on line 373. Remaining tiles. This is just next tiles. No, that's remaining tiles, not just the ones that could be valid next. Seven undefined method tile. Oh, we already have the size. This is just a proxy for size. Okay. New method error variations. Okay, variations is the fun one to do next. This is definitely not the most efficient way I could do this. I've written so much code. Oh, I have some more things to think about too, because I'm probably generating multiple this whole variations thing is going to cause me to have multiple versions of different tiles or something, probably. Anyway, glad I split this into 2 recordings so that I can upload them separately, because this is a 3-hour session we're at right now. So we want assert equal This one's tough. I'm gonna be really pain to write. So first I'm gonna simplify the tile. So it's a little easier. There we go. Because there should be 8 of them. Just trying to make this a little easier to format here. So let's do the rotations first. I guess I need to keep the original one, so I should probably do that. So go, I guess it's easier to just step through them. And then this one will be true, false, false, and swap true in there. And then finally, that'll be false. And this one will be false. And we'll have true and true. So that's all the rotations without mirroring. And then let's mirror it. And rotate it a bunch more times. Once. So this is going to be, this one's true, and this one's true. And finally, now I better be right about the number of rotations here. So we should have, I think that's right. Method meets for nil class. Okay, well that's a separate issue. Okay. Typo. No dice. Did not return what I expected. It looks kind of similar. So let's just extract this. question is, I set up my data wrong. So there are 2 that are in variations that aren't expected, and 3 that are expected that aren't in variations. So those are our 3 that are in variations that aren't in our expected. And vice versa. Those just aren't variations of this one. Oop, I must have messed something up. Because they are, yeah, I must have messed something up. Yes. These ones are not right. Should be false. That should be false. Oh. And that should be false. Cool. So we're calling meets on a set. So that's, oh, probably flat map, not needing to be 2A'd. Where's that happening? Line 366. Map variations, flat map, 2A. Number of arguments, line 421. It's line 428. And we are supposed to pass it with no, that's what we're supposed to do. Well, that finished. Didn't produce the expected result, but it did something. So it returned a tile in the end, not an image. Which is interesting. I want the image. I'm not sure I did this right. I have some suspicions, but I don't think this is doing the right thing. So I think we're getting the wrong result right now, but I think we're close. So image.full, image.valid, image.values.map. This is where I'm going to say values. Image.data.values.map ID. I suspect. Oh, what is this again? Image.map values.map ID. 1, 2, 3. Okay, it worked in that instance. I think it's probably, I don't think I've done anything to make sure it doesn't select values multiple times based on their ID. Or for my input, it didn't matter. Well, I want to fix it though. Okay, so now I just need to solve the corners, or multiply the IDs of the corners. So now that I have a full image, I can say image dot tile at 0.id times image dot tile at, or sorry, 0, 0. Tile at 0 size -1 dot ID times image tile at size -1 0 image tile at size -1 size -1. And find there's no tile at 0, 0, eh? Sus. I mean, it's gonna be 0. What the hell? Whoops. It's right there. 0 times size plus 0. Yeah. Hmm. was something weird with my floating point, or just because it's a float or a big decimal, whatever that is. Okay. Don't know how other things are working, given that that's broken. But okay. Where am I computing that? Size gets passed in. Oh, because in my tests it works, but in my production code I'm computing it, am I? Size. Image is an array. Intriguing and unexpected. That's confusing. That's a tile. Okay, suddenly feeling less confident. And that's just infinite, going off to infinity. So something's wacky. So solve is returning. Oh, this is... confused as to how we went from computing what appeared to be a valid solution to not so quickly. Yeah, that's not finishing. My MacBook Air had a fan in it. I could probably get it to spin up doing that. we just had minus tile in here. And that shouldn't change this. Curious that it's, yeah, it's just taking forever. That shouldn't happen. Shouldn't happen anyway. How was I computing a real thing before and now I can't? What I had before looked like a valid solution. My validation said it was valid. What did I just change? So I fixed logic about determining where oh, probably weren't valid solutions. Dang. Dang, dang, dang. So now we're just getting to the part where I admit that like my approach is really, really slow and probably not viable. Because like what? I would expect it to finish for the 9 though, right? Because 8. Well, it's possible this works, but it's too slow. Oh boy. So I think I need to think more. I think I need to think back to oh boy. Well, this isn't going to finish. I need a little water break here. I will be back momentarily. All right, I'm back. I have water. This has not finished, which means no bueno. So coming back to this, we know that there's, I'm going to commit this. Day 20 part 2 might work, but too slow. How many combinations would there be for like a 4 grid? Enough that it would finish. So I guess we could validate this for a tiny example, right? I mean, this is always going to produce the same result, but since all the corners will be always all the corners. I can't actually make this one even unique. So just want to see if it finds us a solution, which would be 1 times 2 is 2, times 3 is 6, times 4 is 24. Doesn't find a solution. Well, that sucks. Okay, back to the drawing board. What do we need to do to make this work? Besides stay hydrated. Get rid of that. So we know that all the possible edges maybe we can work with this. So we know what we have does not work, so let's take a little step back here. Poke around and pry some more. So I have all these tiles. And what was the thing we did? We mapped them to their possible edges. Then we flat mapped them. Then we group by itself and transform values length. That gives us a count of all the occurrences and shows that some edges only appear a single time. So let's call this X. input dot one, two, three, four, five, six, 7, 8, 9, 10. Oh, sorry, this is. So what I just did was for the sample input, I just computed the tile that has to go in the middle, because it's the only one that has 4 edges that go like that. All 4 corners have matching friends. I mean, that computes our 4 corners. So this will work for our sample input anyway. Right? What, does that make my test pass? Oh, sorry, X doesn't exist. X. What did I grab that snippet? Just need to see if that's the actual answer. I'm skeptical it is, but it is. Okay. That's hilarious. Just need to step away, and there we go. Wrote a lot of code that is not in use there or anywhere in a lot of this stuff, but day 20 part 1, there it is. That's funny. All right, so we found the corners without actually computing anything else about this thing. Good stuff. Now you're ready to check the image for sea monsters. The borders of each tile are not part of the actual image. Start by removing them. In the example above, the tiles become okay. Remove the gaps and form the actual image. Now that you're ready to search for sea monsters, because your image is monochrome, a sea monster will look like that, of course. When looking for this pattern in the image, the spaces can be anything. Only the hash needs to match, sure. In the image above, after flipping and rotating it to the appropriate orientation, there are 2 sea monsters marked with 0. Determine how rough the waters are in the sea monster's habitat by counting the number of hash that are not part of the sea monster. Part of a sea monster. In the above example, the habitat's water roughness is 273. Well, this requires us to actually solve the puzzle, though, which is unfortunate because we weren't actually doing that. We just worked around it. Because that just gets us right back where we started. We have a lot of tools at our disposal, though. And an exceptionally long input to use. Okay. For part 2, we expect the result to be 273. And there we go. We hard code it and everything's fine. $273. Problem solved. Okay. So what do we do? I mean, we can find corners. So this is corners map ID. I don't even know what to call this, but I'm extracting it into a method. And we can extract corners to a method. We can get edges. And we can get, oh sorry, let's call these corner tiles, edge tiles, and center tiles. Oh, too far. This is like 600 lines, 700 lines of code right now, including tests. Okay. Thank you, chat, for sticking with me through this. So we get in here. We have corner tiles. 4 of them. We have center tiles. 1 of them. We have edge tiles. We should have 4 of these too. 1 edge tile. What? Okay. It's a 3 by 3. center tiles, 4 edge tiles, 3. Oh, I see a problem. I see a problem. Okay. Edge tiles length 4. Corner tiles length 4. And center tiles length 1. Beauty, that's all 9 tiles. Edge tiles length, center tiles length, corner tiles length. Okay. So we can do this, right? We can construct this thing just like sort of semi-manually with this information. And just like rotate all the tiles, and like we can place all the tiles where they need to go. Or can we? So there's going to be multiple ways, like, so the reason the orientation doesn't matter in this puzzle, as I understand it, is because all of the tiles laid out one way will be valid just as much as all of the tiles rotated once or mirrored. So there's no way to make the mirroring and stuff matter without giving the tiles an orientation. So we can start by placing one of our corners. Just placing the first corner in the, placing the first corner in the corner. And just going around the edge of the puzzle. And then the only ones that fit should be the ones that fit. So we should just be able to rotate through the inside. Just placing them correctly. Methinks. All right. So this has to do that, but we have work to do down here. So solved image is going to be a thing, and we're going to have to build it up. So but we can do it pretty much straight iteratively, I think. Because once we have the whole edge, so the edge is only going to fit in one way. And then once we have the edge, every tile, we just have to find the rotations for the tiles to place them in. I think. So let's build our, let's say image equals image.new size. And the first thing we'll do is we'll set image equals image.set position 0 first corner tile. Just gonna invoke solved image in here. So now you have an image And we don't care about, we just need a rotation where the bottom and the top and the left, or yeah, the top and the left edge don't match anything. So this is top left. Top left equals top left dot variations. Find. We want one where x t dot top edge and is 1 and x t dot bottom or left edge. Okay, so we place it in the top corner. And then we do size -2 times something. Do something. This is more work than it needs to be. Right? We can just do a single pass over and fill the whole thing out once we have the first corner. Can't we? I guess that's what I'm doing. But I think my constraint thing needs to be smarter because I need to be able to say, what the yeah. So we place one, so we have 133 to go. So in fact, we don't even need to do this work. We're being too smart here. Too smart. Because if it fits, it fits. So find match, so tile, let's find match for So given the image, given the remaining things, given the index, we find the match. Image equals image dot set n tile, and then we should just come out the other side with an image, right? Without any of this shenanigans. Find match is going to remove the match from the input, so takes an image, takes an index, takes the tile, possible tiles, constraint equals image dot get constraint n. I mean, we can just reach into it. But I think that means we need to mess with how tileat works, because I need to know if it's off map or not. Turn out of bounds. I'm not even sure we call valid anywhere. I broke invalid though. But I don't think we need it. Okay, we're not going to actually use get constraint. This whole using indexes for some of this and other things for other stuff is not cool. Why did I do this to myself? And here I am doing it again. Image dot get at. So we're going to do the same thing. We're going to do top right, bottom left. So top is x, y minus 1. is going to be ugly. And so top right is +1, bottom is +1, and left is -1. This is some ugly code that I'm writing. So this is going to return like potentially like a bunch of tiles and or symbols. Let's just write them all out and then maybe we can make sense of this. All right. Image.get at x, y. If z is a tile, then we return tile dot, or sorry, we return z dot bottom edge. Otherwise, we return z itself, which will just be a symbol. And this get at is wrong. It is -1. So we can write that. Top right, bottom left. I'm sure I've massively overcomplicated what I'm doing, but this is where we're at now. Right does +1. Bottom is x. I have to go back and fix which edge I'm picking on each case. I'm aware of this in case anyone's concerned. I mean, I'll forget to do it momentarily, but so for the left we care about the right edge. For the bottom we care about, come on fingers, the top edge, and for the right we care about the left edge of the adjacent tile. Okay. So now we have build constraint, and like hypothetically we can get to there. Let's see, did we actually get that far? Index on line 570. Yeah, these are both supposed to say n. Get at was supposed to be tile at, wasn't it? The find method is these were all supposed to be is a question mark. Top right, bottom left. So that's right. Top and left are expected to be out of bounds. The other two expected to be unknown. So we just need to find the first tile that fits those constraints. And I think the first tile here doesn't matter. So find match is going to go input find tile, or sorry, just tiles. I mean, actually, we don't need to pass tiles in here. We're going to just manipulate it anyway. Like that, and then we just need the logic in here. Probably we might want to orient it correctly right here, but that is fine. Okay, so if we implement matches constraint correctly, then kind of don't want to duplicate work though. Whatever, let's not worry about it. What? And then we just need to implement matches constraint. So we could have done this. I can see so many ways we could have done this more simply, but we're getting there. Okay. So we have a bunch of conditions that we need to be true, essentially. Top edge matches constraint, bottom edge matches constraint. So we can say constraint zip. We'll zip it with tile.top edge, tile.right edge, bottom edge, tile.left edge. To pair up the constraints. And then we just need to ask something about the constraint and the edge. So if array, then we return C is E, else if C is out of bounds, we have something, else if C is unknown, we have something else. So if C is out of bounds, then what we care is that X E is 1. If C is unknown, then we care that it's 2. Find method variations for nil class. 573. Well, that sucks. Out of bounds, out of bounds, out of bounds, out of bounds. Well, that's silly and wrong. So that's not just, that's 100% just not the right thing. So what is going on? That so much code to navigate in one file. Part 2 test. Okay, sorry, or right here. Build constraint. Well, that's very interesting. So image should have a tile at 0. And it should be one of the corners. I assume that's a corner. So n is size is 3. X should be 1. Y should be 0. N is 1. N% size is 1 as expected. Did I do this wrong? Totally did, didn't I? I did this in a bunch of places. How did I not notice this until now? What's the actual logic? So if I have n minus x divided by size, Yeah, I think that's right. Well, good thing I've spread that logic like all over the code base to make it really annoying to fix. Oh, I guess there's only the 2 occurrences. Oh, that looked like it solved it. Let's try and use the new solution in part 1. Seems fast enough. So just gonna insert that here. We no longer use these. And we can implement corner tiles as a method. So I tile at 0, 0. I tile at 0, size -1. I tile at size -1, 0. So our tests still pass, which suggests that we now have a working proper solution. One thing I want to do before I go any further, though, is we can check if I is valid. Oh, did I remove that? Oh, I did remove that. Sadly. Well, let's assume it's valid. All right, so. Now that we have this, we need to do the rest of the problem. Oh, we made this so much harder for ourselves than we needed to. That's not gonna work though. I can't use a here doc for this. I can't use a squiggly here doc. Okay. Now I take it. So next I need to create the actual image out of. Yes, Metalhead. I have been I've been streaming for almost 4.5 hours now. but I also completed the previous days. So take that however you will. But let's see. It says I've been recording 3 hours, so the last 3 hours or so have been this problem. I've struggled with it, but we got past part 1. I think I've built something that produces the results, so now it's a matter of finding these monsters, and I think that's relatively easy now. Yeah. I found a cheeky solution for part 1, but then part 2 provided that didn't involve building the image, and then it was like, oh shoot, I have to actually build the image. Monster finding bit is easy compared to the rest. Yes, I expect so. I just gotta actually produce the corner tech. Yeah. Find the ones that only have 2 sides that match anything else. Yeah. Nice. I think I just need to convert this thing back into what I need. So I have to remove all of the edges. This is where I start to just want it as a big array, or whatever, array of arrays, whichever. Just need to turn it into something I can use here, because what I've got in here is not exceptionally useful, because it is still just a whole bunch of, tiles. So I gotta compose them again. It's probably the right thing to do. I guess the first thing is to trim them. Let's see, I can take them out in so I have them by their IDs as they go across. So let's start to write that code. There we go. So oh, it does not like this. Let's just ignore that for now. I'm getting confused by, oh, I'm in, it wasn't that, it was that I was still in paste mode. Okay. Oof. I'm doing this for too many hours now. It's only 3 hours till the next one. That's what I get for falling behind. Real image. I guess there's some risk that I'm going to need to rotate it, right? Because I don't know the orientation. But I guess only one orientation has sea monsters, so once I have a check for that, rotating it should be easy. Okay, let's do that. So if we have our solved image, then our map dot I'm just gonna pry in here. Whoops, I gotta invoke that. So I.map is still this. In 2a it to get pairings of that. We could do sort by first to make sure that they're all in order, though they should be, because we're inserting them in the right order. So I map index tile, and I want to be able to just trim the tiles. So that gives us a list of tiles in order, and this trim thing just needs to be implemented somewhere way further up this file. I can set. So it's easier when I'm jumping around. I'm just going to put the line numbers on. Struct implementation, we didn't use some of it, but that's fine. So let's test trim. And we're just going to do it on a tiny tile. Assert. Just gonna our expected tile is going to be same ID, but it is only going to contain a false, a single row. Okay, that was maybe not. Let's make it a 4x4, so that it's a little better of an example. So then what we want it is false true on the first row and false false on the second row. There we go, it looks a little better. Running tests, that fails as expected because we haven't implemented it yet. And okay, so this is tile.new. We pass in the ID, and then we take the first to second to last rows, and we map those to be only the first to second to last elements. Ha! Okay, that works. So now we can trim our things down. Just the way we need to. And oh boy, we have generated too much code, especially since a ton of this isn't even in use, but we're here. So we trim the images. So this is now like working. But this isn't. Okay, so tiles here are now these shrunken tiles. First, last, 8. Is that right? I dot map. Okay, yeah, so they're 10 by 10s. Okay, that's fine. Okay, I think we can do this. Okay, so now that we have these mapped to their indexes, I don't think, actually we don't even need to do, we don't even need their indexes anymore. We really only need tile.trim.data at this point. And then the tiles, these are going to be these. So then we need to take them in chunks. Let's check enumerable. I think that might be our friend here. Each slice. So 1 to 10, 1, 2, 3, 4, 6, 7, 8, 9, 10. Yes, that's what we want. So we want to do something like, let's just write it in the editor. It's easier. Tiles, each slice, size, which is the size of the grid. Can you just like, guess it's slice. What am I thinking here? Map, am I mapping this? Flat mapping this? Maybe? I'm trying to wrap my head around this one. Slice 0 zip slice 1 to -1. Does that produce something vaguely like what I'm expecting? It does not initially look like it. There's like nested data or something in here. $24. Is 24, what's 24 the number of? We have, it's a 9 by 9. Actually, this is 3 by 3. They were 10 by 10, or 8 by 8. 3 times 8 is 24. Yeah, that's right. Okay, this is coming along, but this data looks weird. I don't think I've sliced this data up right. So like size 0. Oh, sorry, what am I doing? Y0 is an array with an array with an array of more arrays in it. Ah, I know what I did. I meant to do that. Yeah. And almost there. Do we need to join those? That makes a row, right? Is that what I'm joining? Oh, this is hard to think about. Let's just see what that is. I think that's probably wrong. Yeah, that's definitely wrong. So 0 should just be the rows, right? And then we can join the individual rows or concat them. Not join. I keep calling join. This is going to be just garbage again. But like the right garbage. Or flatten them. Just flatten the rows though. This looks right. This is what I was trying to get out. Yeah. Oh boy. That is a nasty one, but it works. Still need to be able to rotate it to find the variation that has monsters in it. Then delete the monsters, count the things, and go have some dinner before it gets any later. I guess. So I guess we need to write a check to find out has monster. Let's be like R equals rotate R until has monster R, and then we can what do? We R equals or R equals remove monster. What do we want to do? Something. Remove monsters. Count things. Count waves, I guess. Okay. So has monster. So we can loop 0 to size -1. Each do X. Same thing for Y. Oh, not -1 though. So the minus like 4. And it's this length here. It's 21. Sorry, it's 21 here. And 4 there to avoid trying to look for them off the map. And that's where it gets a little tricky to visualize. So our X and Y are swapped. So it's like R, Y, X to check if a tile is valid. And I guess we just want to, we need all of the coordinates of the spots that are on the monster relative to here. So this is 0, 0, and this is 0 plus 1, 0, 1. This is where I'm going to screw something up, and it's going to by manually doing this. Should I parse that image? Should I parse monster? That seems like conceivable. Monster dot it's so ugly to do that though. Each with index 2, and that's the, I'll probably pull this out, but that is the Y value, and the row, probably the other way around, isn't it? Row Y, and row dot chars dot each with index this is a flat map. Dot select. We only care about ones where I can use X in here. It's safe. This is bad though. X equals that map I just want to see if that's right, if that actually works. That never got invoked. Intriguing. What? Do I have a rotate method on? That didn't work. Oh, yeah, that's wrong. I see. check the wrong thing here. So we should have one at 0, 1. This looks right. So monster dot all for any XY, there's a fully hanging out monster there. Now, fortunately, we already have some rotate code hanging out here. Mm-hmm. We're only ever doing this once, so I'm getting off track. Any tile.data just needs to be replaced with R. Oh, but we need to then horizontal flip it. Horizontal flip is just a map through reverse. Excuse me. 681. Looks like I have an extra paren in there. Okay, that's not working. Distinctly not working. Which is upsetting. Things were looking so good for us. Roxy's hanging out in here because it's almost her dinner time. She always wants to be nearby. Being very attentive despite laying down and not moving her body otherwise. Just staring at me every time I look over. I mean, we can do some tests here, I guess. We can try and rotate a simple one. So R is going to be this big thing that's hard to work with, but we can make a simple one. True, false, 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 true, false, false, false. Let Z, Z equals rotate Z, or sorry, we'll just call rotate Z. So we expect for rotating clockwise, the elements along the top will be on the right edge, so true, false, false should be true, false, false. The elements along the bottom edge, false, 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 should now be along the left. Elements along the, should still have a false in the middle. On the right hand side, false, true, false should be on the bottom, false, true, false. And the left side, false, false, true should be on the top, false, false, true. So my rotate is working. Something else is off. I have a sneaking suspicion it is has monster. So maybe we should, oh, it's so hard to debug this though, just because of the size of the data. I mean, we can poke around. So got this giant thing. There should be like a debugging. It's probably worth just doing it here. Let's, for the purposes of debugging and trying to inspect. Map each row into what am I doing here? Map each row, and then with each thing, we say X is true. We do that. Otherwise, we do a dot, and we join that and join the whole thing with new lines. Like that. Yeah, there we go, that's helpful. And now we can look for sea monsters. So in our example, they conveniently gave us some, so we should be able to find one starting 4 rows down and 3 columns in. 4 rows down, 3 columns in. We find one there, one there. Let's get 2 over. So yes, we should be able to find one right there. That is present in ours. So it looks like we are getting the same map and the same everything, but we are not getting, it is failing to detect it. But we now know that it is beginning in position 1, 2, 3, 0, 1, 2, 0, 1, 2. So we can say binding.try if x equals 2 and y equals 2. Interesting. We're never getting there. Size. Oh, size is the wrong thing here. It's like size times in fact, let's just not use size at all here. Let's just use That's just risky. This is r.length. Okay. That passed all tests and didn't produce a result, but I think things are working now. Like, we print this out, it is printing it out in the correct orientation, so now we can do this. Now we can do this. So remove any erroneous binding up prize, and so it's going to return the coordinates if they exist. So we need to remove the monsters. So for each so we can just add, so we can do a little math here to set y plus my, x plus mx equals false to wipe out the monster. And the answer should be r dot flatten count itself. That's just to count the ones that are true. What do we do? We did not like this thing that I did. Uh-oh. Oh no. I would not describe that as working. Right. I don't actually even know what that does when has monster returns false. X, Y equals chords. Not great. So yeah, that'll error because I put them in the wrong spot. It's just always finding 0. Excuse me. Oh, this isn't right. What am I doing here? Oops. Well, it passed. It works for the small input. Is it just working slowly for the big input? I guess it's looking up all the monsters for everyone. So maybe that's can a tile be made up of multiple spaces can be anything. All you need is rotate. After flipping and rotating it, there are 2 sea monsters. Determine how can sea monsters overlap? Doesn't say. This is not. I'm not optimistic about that. That run taking so long. Has anyone who's completed this know if sea monsters can overlap? So I can refactor it to sort of take advantage of that if I want. If they don't. They don't overlap. Okay. Also works. I want to know where we're getting to. Uh-oh. So I think we're rotating forever. Good code, really good code that we're writing here. Okay. Oh, that doesn't help us because we're overwriting the variable. Better. R. So this is our full size one, 96. But my code doesn't see any. All right, I gotta break for 30 seconds here. Be right back. All right, we're almost there. We're so close. Now the problem is my code is not seeing a single I don't know why I'm staring at this. So we can print it out. There's a lot of stuff to look at. It's also unfortunately pretty sparse. It's going to be hard to spot them. Might be easiest to spot by the nose. Even then, there are only two. There are only two in the test input. Are there definitely only two? In the above image, after flipping rotated, two sea monsters. Yeah, it just says in the above image. So I don't know if I should expect more or less. In my actual input. Having trouble seeing any though. Come on, pattern matching brain. Find me a sea monster. Dang it. I mean, there might not be one in this rotation. Yeah, I would expect there to be many, though I don't see any. I don't see any in this rotation. Yeah, 2 is for the sample input, yeah. Yeah, and mine's working correctly for the sample input, which is the upsetting part here. Do we see any in here? There's almost one over here, but not quite. Yeah, it's tough when it works for the sample input, but not.
Motorcycle gangs scavenged the lands and terrorized the population. As such, main force patrol, an outrun police
But not
force, has been created to
IRL.
patrol the lands
It just keeps rotating it until.
and justice.
So is something else the matter? Is my rotate wrong? Are you flipping too? No, I'm not flipping. Thank you. Thank you, Metalhead. Yeah, there are 8 possible orientations, and I am only checking the four of them. Oh boy, good one, good one. This is some beautiful code, but let's see if that was the problem. No, putting too many commas and things is the problem. Putting not enough commas and things. Too many commas isn't a problem. Oh boy, I hope that's the right answer. There we go. 1 gold star. Credit goes to Metalhead for pointing out that I was forgetting to flip the images, or the image at the final step. But I'm very hungry, so I'm going to go eat. Thank you everyone for coming out along this long journey, this almost 5.5 hour stream. I will be back again in shortly before 9 to tackle day 21 when it drops. See y'all later.